Optics is the branch of physics which deal with the study, nature and property of light. It is divided into two types, ray optics and wave optics. A highly polished surface which reflects most of the light falling on it is called mirror. A point at which rays after reflection or refraction actually meet is called real image. A point at which rays after reflection or refraction appear to come from is called virtual image. A real image is always inverted and virtual image is always erect. The phenomenon in which light after falling a certain surface travel back in the same medium is called reflection. In a reflection, angle of incidence is equal to angle of reflection. A spherical mirror whose reflecting surface is curved inward is called concave mirror, and if reflecting surface is curved outward then it is called convex mirror. Center of sphere of which mirror form a part is called center of curvature, and its radius is called radius of curvature. Midpoint of spherical mirror is called pole. Line joining pole and center of curvature is called principal axis. Point on the principal axis at which a narrow beam of light parallel to principal axis after reflection or refraction appear to come from or meet is called principal focus. The distance of pole and principal focus is called focal length. All distances are to be measured from the pole of the mirror. Distances in the direction of incident ray are taken positive while opposite to it are taken negative. Height taken in upward direction perpendicular to principal axis is taken positive while in downward direction it is taken negative. Radius of curvature of any mirror is 2 times the focal length of the mirror. Relation between distance of object, image and focal length is called mirror formula. 1 upon u plus 1 upon v is equal to 1 upon f. It is proved by taking two triangles of object and image with pole and center of curvature and then equating the ratios of their sides. The ratio of size of the image to size of the object is called linear magnification. It is denoted by small m. M is equal to minus v upon u. For plane mirror, m is equal to plus 1 and f is infinity. Concave mirror are used by dentist, eye specialist for shaving, in cinema projectors, in refracting type telescope, for solar cookers, in motor headlights and torch etc. Convex mirror are used in vehicle, in street lights, in mall to monitor the activities of customers etc. The inability of a spherical mirror of large aperture to bring all rays of beam falling on it to focus a single point is called spherical aberration. The ratio of size of the surface of image to size of surface of object is called surface magnification. The phenomena of change in the path of light when it goes from one medium to another is called refraction. When it goes from rarer to denser medium then it bends toward normal, and when it goes from denser to rarer medium it bends away from normal. The ratio of speed of light in vacuum to speed of light in medium is called absolute refractive index. It is a number having no units and no dimension formula. The medium having large value of refractive index is called optical denser medium. It is 1 for vacuum. It is inversely proportional to wavelength. Therefore, its value is greater for violet color than red color. Refraction occurs due to change in the speed of light when it goes from one medium to another. Frequency of light does not change. The ratio of sine of the angle of incidence to sine of the angle of refraction is constant for a pair of medium and it is equal to relative refractive index. This is known as Snell's law. If path of a ray after refraction is reversed, then it retraces its path. Refractive index of medium 2 with respect to 1 is reciprocal of refractive index of medium 1 with respect to 2. A ray incident obliquely on the parallel glass slab emerges out parallel to the incident ray, but it is laterally shifted. The depth of an object lying in the denser medium appear to be less than the real depth, or the object is appear to be raised due to phenomena of refraction. Therefore, relative refractive index of medium 2 with respect to 1 is also equal to real depth upon apparent depth. Object dipped in water appear to be shortened due to refraction. Stars appear to be twinkling. Sun appear to be flattened. The phenomena by virtue of which a light traveling from denser medium to rarer medium at angle greater than the critical angle is reflected totally back in the denser medium is called total internal reflection. The angle of incidence for which angle of refraction is 90 degrees is called critical angle. Relative refractive index is also equal to reciprocal of sine of the critical angle. The phenomena of total internal reflection is used in poroprism and in optical fibers. Optical fiber are used to transmit light without any loss, to manufacture medical instruments like endoscope. They are used in telecommunication and also to form toys. There are some numericals. A portion of a refracting medium whose curved surface form a part is called spherical refracting surface. It is of two types, concave and convex. Aperture of spherical refracting surface is taken to be small. Object is considered as a point object lying on the principal axis. There are 6 cases of refraction at spherical surface. 4 cases are for convex refracting surface and 2 cases are for concave refracting surface. First case is when object lies in the rarer medium and image formed is real. Second case is when object lies in the rarer medium, image formed is virtual. In third case, object object lies in the denser medium and image form is real. In fourth case, object lies in the denser medium and image form is virtual. For concave refracting surface, which always form virtual image, object lies in the rarer medium is the fifth case and object lies in the denser medium is the sixth case. If object lies in the rarer medium, then the relation comes minus n1 upon u plus n2 upon v is equal to n2 minus n1 upon r. And if object lies in the denser medium, then the relation is obtained by interchanging n1 and n2, where n1 is the absolute refractive index of rarer medium and n2 is the absolute refractive index of denser medium. Piece of transparent material bounded by two refracting surface, out of which at least one is curved, is known as lens. Lenses are commonly used to correct the defects of vision of human eye and in microscope, telescope, cameras, projector, etc. Some assumptions: lens is thin and all distances are to be measured from the optical center of the lens. Object is a point object situated on the principal axis, and angle made by incident and refracted ray with principal axis are small angles. The equation which relate the focal length of a lens with the refractive index of material and its radii of curvature is called lens maker's formula. To derive it, we consider refraction at first surface when object lies in the rarer medium and image form in the denser medium. Then we write the relation for refracting surface. For second surface, the image of the object act as an object placed in the denser medium, and finally make the image in the rarer medium. We again write the equation for refracting surface when object lies in the denser medium and then solve these two equations. We can also derive lens maker formula for double concave lens. It is same for two lenses, that is 1 upon f is equal to n minus 1 into 1 upon r1 minus 1 upon r. First principal focus is the position of the object for which image lies at infinity. Second principal focus is the position of the image for which object lies at infinity. Both focal lengths are same. The relation among the distance of object, distance of image from the lens and focal length of the lens is called lens formula. It is same for convex lens or for concave lens, which may be the image, may be the real or may be the virtual. It can be proved in the same way as the mirror formula. In case of lens, linear magnification is equal to minus v upon u. Power of a lens is the measure of convergence or divergence of rays of light falling on the lens. It is defined as the tangent of the angle by which lens converges or diverges a beam of light falling at unit distance from optical center. It comes out to be the reciprocal of focal length of the lens. Its SI unit is diopter. Power of a lens is inversely proportional to square of the wavelength of the light. Focal length of a lens changes when it is immersed in liquid. When thin lenses are combined, then the focal length of combination is called equivalent focal length. In combination of lens, equivalent focal length, power and magnification of the lenses changes. Reciprocal of equivalent focal length is equal to sum of reciprocals of focal lengths of two lenses. When lenses are at some distance, then the reciprocal of the equivalent focal length is equal to sum of the reciprocals of the focal length of two lenses minus the distance divided by the product of the focal lengths. We can combine a lens with a mirror. Image formed by the lens act as an object for the mirror and it makes the final image. We can find the power of the combination of lenses or mirror. Convex mirror always form diminished virtual image of the object on the other side of the mirror. Concave lens also form diminished virtual image but on the same side of the object. Concave mirror and convex lens form the virtual image of the object when object lies between their pole and focus. Then there are some numericals based on the combination of lenses and mirrors.
3, 2, 1.
Prism is a portion of transparent refracting medium bounded by two non-parallel plane surfaces inclined at some angle. By studying refraction through prism, we find that the angle of deviation plus angle of prism is equal to angle of incidence plus angle of emergence. There is only one angle of incidence for which the deviation produced by the prism is minimum. For minimum deviation, the refracted rays pass parallel to the base of the prism. At minimum deviation, I is equal to E and R1 is equal to R2. Therefore, we can also find the prism formula. Deviation produced by the prism of small angle is given by the refractive index minus 1 times the angle of prism. The devices that work on the principle of reflection and refraction of light are called optical instruments. For example, periscope, kaleidoscope, binoculars, telescope, microscope, etc. Human eye is an optical device which acts as natural camera. Light enters the pupil through cornea and make the image at retina, which sends the signal to the brain. There are basically four defects of eye: myopia, hypermetropia, presbyopia, astigmatism. In myopia, person can see the near object clearly but is unable to see the far off objects. This defect can be removed by using concave lens of suitable focal length. In hypermetropia, person person can see the distant object clearly but is unable to see the nearby object. This defect can be removed by using convex lens of suitable focal length. In presbyopia, person cannot see the nearer as well as the distant object clearly. This defect is due to age factor. In astigmatism, person cannot focus in both horizontal and vertical planes clearly. This defect occurs when the cornea is not spherical in shape. The ability of an eye to focus object at different distances is called power of accommodation. It is equal to 4 diopter.
3, 2, 1.
A convex lens of small focal length is called simple microscope or magnifying glass. When object is placed between the optical center and focus of the convex lens, it produces magnified virtual image on the same side of the lens. Image may be adjusted at least distance of distinct vision, that is 25 cm, or at infinity, that is normal vision. Magnifying power or angular magnification is defined as the ratio of the angle subtended by the image at eye to the angle subtended by object at eye when both are placed at least distance of distinct vision. For normal vision, magnifying power is equal to d upon f, where d is 25 cm, and when image is from at least distance of distinct vision, then magnifying power is equal to 1 plus d upon f. Compound microscope is an instrument used to see extremely small objects. It consists of two convex lenses. A lens of short aperture and short focal length facing the object is called objective, and a lens of short focal length but large aperture is called eye lens. Object lens make real inverted and magnified image of the object on the other side. This image acts as an object for the other lens and it forms the final virtual magnified image on the same side. For least distance of distinct vision, magnifying power comes out to be minus L upon f naught into 1 plus d upon fe, where f naught and fe are the focal length of objective and eyepiece respectively. For normal adjustment, magnifying power is equal to minus L upon f naught into d upon fe. Telescope is an instrument used to see distant objects clearly and magnified. It is of two types, reflecting type and a refracting type. Astronomical telescope is a refracting type telescope used to see heavenly objects like moon, star and planets. Objective is a convex lens of large aperture and large focal length. Eyepiece is a convex lens of small aperture and small focal length. For least distance of distinct vision, magnifying power comes out to be minus f naught upon fe into fe upon d plus 1. For normal adjustment, magnifying power is equal to minus f naught upon fe. Terrestrial telescopes are used to see objects on the earth. They consist of three convex lenses. A good telescope should have large magnifying power, large resolving power and large light gathering power. Reflecting type telescope consists of Cassegrain telescope and Newtonian telescope. Here objective lens is replaced by paraboloidal mirror of large aperture. Reflecting type telescope are free from chromatic and spherical aberrations. Final image is sharp and bright. Light gathering power is large. They are used in astronomy and they are not handy. The mirror weight is less and full back of mirror can be spotted. Some numericals, and thanks for watching.